everyone, welcome to topic 7.1, testing a claim or idea, the chi-squared test. Okay, so for this topic we'll start with an example. Here we have a contingency table. First we have age groups, under 35 and 35 years and older. Next we have brands, Under Armour, Nike and Adidas. As you can see, this is categorical data where out of 600 sales we have the number of sales that fall in each category. For example, 174 sales were by people under 35 years old and purchasing the Under Armour brand. Here we might be interested in whether certain brands attract certain age groups. In particular, we might be interested in whether there is a relationship between brand loyalty and the buyer's age. Another way of saying this is to ask the question, is brand loyalty dependent on age of buyer? Here are the hypotheses. As you can see, the research question on the previous slide appears in the alternative hypothesis. So first, the null hypothesis states that brand and age of buyer are independent, or another way of saying this is that there is no relationship between brand and age of buyer. The alternative hypothesis states that brand and age of buyer are dependent, or there is a relationship between brand and age of buyer. The data for the chi-squared test of independence is normally displayed in a contingency table. Each variable has two or more categories, and the test of independence is based on comparing observed frequencies, so the data, to the expected frequencies. Here is the data again for this example. This is our observed data. Next we need to calculate our expected frequencies using the formula shown on the slide. E equals the row total multiplied by the column total and divided by the sample size. Next we calculate the chi-squared test statistic value. We do this as follows. Chi-squared equals the observed value for a particular cell, subtract the expected value for that cell, and then we square this number to avoid cancelling out positive and negative values. Then we divide by the expected value for the cell. This is done for all cells and then summed. So now have a go at some calculations. Here you can see the first one is done. To calculate the expected value for row 1, column 1, which is age under 35 and brand Under Armour, we multiply the row total of 396 by the column total of 228, then divide by the sample size of 600. This gives us the expected value for that cell of 150.48. Now it's your turn. Please press pause on the video and attempt bullet points 2 and 3. I'll provide the solutions next. Okay, so for bullet point 2 we just need to calculate this through. So if our calculator is working, you should get an expected value of 134.64. For bullet point 3 we need to work out E13, which is the expected value for row 1, column 3, which is age under 35 years old and brand Adidas. So this is calculated as 396 multiplied by 168 and then divide by 600, which equals 110.88. Okay, so here we have the expected frequencies in the first table and then the deviations in the second table. These deviations are the differences between the observed and expected values for each cell. Notice how there are positive and negative values. Okay, so before we move on to calculate the chi-squared test statistic, I should just mention one assumption of the test. One assumption of the chi-squared test is that in each cell the expected value is at least 5. As shown on the previous slide, our expected values are all above 5. If they weren't, we may need to combine categories. Please note Excel is a little less stringent and only requires expectancies to be over 1. You will see this with the chi-squared output in Excel. Okay, so now back to calculating the chi-squared test statistic. On the slide you can see that the squared deviations have been divided by the expected frequencies for each cell. If we add these together, we get our chi-squared test statistic value of 22.53. Okay, so now we've got to determine if this is significant. Okay, so on this slide we have a reminder of the hypotheses, then we have the formula for the chi-squared test. Next we need to determine our chi-squared critical value, and we need our degrees of freedom to do this. Degrees of freedom are calculated as the number of rows subtract 1 multiplied by the number of columns subtract 1. In our example it is 2 take 1 equals 1 multiplied by 3 take 1, which is 2. So 2 multiplied by 1 equals 2, which is our degrees of freedom for this test. We use this to determine our critical value, which we look up in table 3, which starts on page 734 of your textbook. Have a look with me. Here is an excerpt from the table. So what we need to do is look down at 2 degrees of freedom and then across to 0.05 in the upper tail. This gives us a critical value of 5.991. As a result, since the chi-squared test statistic, which equals 22.53, is greater than the chi-squared critical value of 5.991, we reject the null hypothesis. There is enough evidence to conclude that there is a relationship between brand type and age of fire.